In this lecture, we take one more example on linearly dependent and independent of vectors. The question is, examine for linearly dependence and independence of the following vectors. Find a relation among them if they are dependent. So these three vectors are 2, 2, 1 transpose, 1, 3, 1 transpose, and 1, 2, 2 transpose. So here the vectors are into the form of column vectors. Let us get its solution. We have to examine for linear dependence of the following vectors. x1 equal to 2, 2, 1 transpose, x2 equal to 1, 3, 1 transpose, and x3 equal to 1, 2, 2 transpose. Let C1, C2, C3 are three scalars such that C1 x1 plus C2 x2 plus C3 x3 equal to 0. Let us give these as equation number 1. Now we substitute the value of x1, which is 2, 2, 1 transpose. The value of x2 is 1, 3, 1 transpose. The value of x3 is 1, 2, 2 transpose, which is equal to 0. And now if you multiply this C1 with 2, 2C1, 2C1, C1. Similarly, if we multiply this C2 with this vector, C2, 3C2, C2. So this can be written as 2C1, 2C2, 2C1, 2C1, C1 plus C2, 3C2, C2 plus C3, 2C3, 2C3 equal to 0, 0, 0. Let us add all these three. 2C1 plus C2 plus C3. This is the first part. First row, 2C1 plus 3C2 plus 2C3. Second row, C1 plus C2 plus 2C3 is the third row, which is equal to 0, 0, 0. Now equating these two column vectors, we have 2C1 plus C2 plus C3 equal to 0, 2C1 plus 3C2 plus 2C3 equal to 0, and C1 plus C2 plus 2C3 equal to 0. This is system of homogeneous linear equation Ax equal to 0. It can be written as 2, 1, 1, 2, 3, 2, 1, 1, 2. Means this 2, 1, 1 is coefficient of C1, C2, C3. Similarly, 2, 3, 2 is the coefficient of second equation, and 1, 1, 2 is the coefficient of C1, C2, C3 of third equation. And this C1, C2, C3 is vector, means variable vector, and 0, 0, 0 is this column vector, or we can say that constant vector. Now we have to reduce this matrix to its equivalent form. So we have to interchange the row number 1 and row number 3 because A11 should be 1. Now using this one, we have to make this and this 0 by applying the following two operations. R2 minus 2R1 in R2 and R3 minus 2R1 in R3. Then the given matrix will be converted into this form. Let us just check it, how it will be converted. Now the second row is 2, 3, 2. We have to multiply the first row by 2. So 2 into 1 is 2. 2 into 1 is 2. And 2 into 2 is 4. And if we subtract it, 2 minus 2 is 0. 3 minus 2 is 1. 2 minus 4 is minus 2. So 0, 1 minus 2. Similarly, if we apply this operation R3 minus 2R1, R3 is 2, 1, 1. We have to multiply this by 2 and subtract it from 2, 1, 1. 2 into 2, 2. 2 into 1, 2. 2 into 1, 2. 2 to the 4. We have to subtract it. So minus 2 minus 2 plus 2 is 0, minus 1 and minus 3. So just look here, the third row is converted in this manner. Now we have to move to A22. With the help of this A22, we have to make this 0. For this purpose, we have to apply the operation R3 plus R2 in R3. Then we have, there is no change in the first row and second row. The third row is 0, minus 1, minus 3. And if we are adding the first, second row, then this 0, 0 is 0, minus 1 plus 1 is 0, minus 3 plus minus 2 is minus 5. So this is the last row. Now, the given matrix is converted into the form of equivalent form because below the main diagonal, all elements are 0. Now we are able to write down this into the equation form. C1 plus C2 plus 2C3 equal to 0. C2 minus 2C3 equal to 0. And minus 5C3 equal to 0. So clearly here, if we take from equation number 4, we have C3 equal to 0 because minus 5 is constant. So constant cannot be equal to 0. So ultimately C3 will be 0. Putting the value of C3 in equation number 3, if we put C3 equal to 0, then C2 will be also 0. Putting the value of C2 and C3 in equation number 2, we have C1 is also 0. Here, all the variables C1, C2, C3 are, we can say that scalars are 0. Therefore, all the values of C1, C2, C3 are 0. Hence, the given vectors are linearly independent. They don't have, so therefore they don't have any relation. Now, this can be also checked by using the, let me go back just. Now, if we see this matrix, here, if we see what is the rank of this matrix, the rank of the matrix is 3, and which is equal to the number of unknown quantities or variable. Therefore, the given vectors are also linearly independent because we know that if the determinant of A equal to 0, vectors are linearly dependent, and if determinant of A is not equal to 0, then the vectors are linearly independent. So here, if we find out the determinant of A, it is minus 5. Determinant of A equal to minus 5, which is not equal to 0. So we are also able to say that the vectors are linearly independent. So this is the one more check about how this is the one more check to check that the given vectors are linearly independent or linearly dependent. So if determinant of A equal to 0, vectors are linearly dependent. If determinant of A is not equal to 0, then the vectors are linearly independent. Here, all the values of C1, C2, C3 are 0. Therefore, the given vectors are linearly independent. Thank you.